Welcome to Star Chat, the podcast where we explore the wonders of the universe and bring you the latest updates from the world of space exploration. I'm your host, Carl, and I'm excited to share some fascinating stories with you today. We're starting off with a story that's out of this world, literally. NASA's Psyche spacecraft, which was launched in October 2023, is experiencing some technical difficulties. The spacecraft is on its way to visit a metal asteroid in the main asteroid belt between Mars and Jupiter, but it's currently coasting due to a problem with its thrusters. Now, you might be wondering what's so special about these thrusters. Well, they use ionized xenon gas to propel the spacecraft forward, giving off a bright blue glow in the process. It's a pretty cool system, and it's designed to be extremely efficient, using tiny amounts of fuel to move the spacecraft through the vastness of space. However, it seems that the fuel pressure in the system has dropped, causing the thrusters to shut down automatically. NASA is still trying to figure out what caused this drop in pressure, but they do have a few weeks to work on the problem before it starts to affect the mission. The good news is that the spacecraft has a backup fuel line, which could potentially be used to keep the thrusters running if needed. And NASA personnel don't seem too concerned about the issue at the moment, with one representative saying that this kind of thing happens, and that they've built redundancy into their missions. It's a great reminder that space exploration is all about overcoming challenges and adapting to unexpected situations. And we'll be keeping a close eye on the Psyche spacecraft as it continues its journey to the metal asteroid. We'll be right back with more fascinating space news on StarChat. Welcome back to StarChat. I'm your host, Carl. We're exploring the wonders of the universe, and today we have a fascinating story that's out of this world. Literally! Imagine a vast invisible cloud of molecular hydrogen floating in space, just 300 light-years away from our planet. This is not a scene from a science fiction movie, but a real discovery made by astronomers using a new technique. This enormous cloud, dubbed EOS, is a dark molecular cloud, which means it's difficult to detect with conventional methods. But thanks to the innovative use of far ultraviolet fluorescence emission, researchers have been able to uncover this hidden giant. The EOS cloud is so massive that if we could see it with our naked eye, it would appear as a vast, sprawling structure in the night sky, dwarfing even the brightest stars. But what makes this discovery truly remarkable is its implications for our understanding of the interstellar medium, the gaseous space between stars. Molecular clouds like EOS provide the raw material for the birth of new stars and planets. By studying these clouds, scientists can gain insights into the formation of our own solar system and the potential for life beyond Earth. The story of EOS is also a reminder of the cosmic journey that has brought us to where we are today. The hydrogen atoms in this cloud have been traveling through space for 13.6 billion years, since the Big Bang itself. They've fallen onto our galaxy, coalesced near the Sun, and now reside in this vast, invisible cloud. As we continue to explore the universe, we're reminded of the awe-inspiring scale and complexity of creation. From the closest molecular clouds to the farthest reaches of the cosmos, every discovery has the potential to rewrite our understanding of the universe and our place within it. Stay tuned for our final story of the day, right here on StarChat. Welcome back to StarChat, folks. I hope you've enjoyed our journey through the cosmos so far. As we wrap up today's show, I'd like to take you on a fascinating tour of some recent discoveries that are shedding new light on the mysteries of exoplanets. You know, the search for life beyond Earth has been a driving force behind astronomical research for decades. And with the help of cutting-edge telescopes like the James Webb Space Telescope, we're getting closer to understanding the complexities of planetary formation and the potential for habitability in distant star systems. Let's start with a remarkable find by NASA's exoplanet team. They've been exploring the properties of exoplanets using a range of innovative techniques, including the wobble method, which allows scientists to detect the subtle gravitational tug of an exoplanet on its host star. This has led to some astonishing discoveries, like the detection of a cold exoplanet that's 6 times the mass of Jupiter, with surface temperatures plummeting to -87 degrees Celsius. That's even chillier than Antarctica in the dead of winter. But what makes this discovery truly remarkable is the fact that this exoplanet orbits a white dwarf star, a remnant of a star that has exhausted its fuel and shed its outer layers. The researchers believe that this planet may have formed further out in the system and then migrated closer to the star over time, potentially entering the habitable zone. Now, you might wonder what implications this has for our understanding of planetary formation and the search for life beyond Earth. Well, my friends, it's a game changer. The fact that exoplanets can survive and even thrive in the vicinity of white dwarf stars opens up new possibilities for the discovery of habitable worlds. As we continue to explore the universe, we're reminded of the awe-inspiring complexity and diversity of celestial systems out there. From the scorching hot to the freezing cold, each new discovery helps us refine our understanding of the cosmos and our place within it. So, as we conclude today's Star Chat, I want to leave you with a sense of wonder and curiosity about the vast expanse of the universe. Remember that the search for life beyond Earth is an ongoing journey, full of surprises and discoveries waiting to be made. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.